This research paper, titled Unsupervised Classification of English Words Based on Phonological Information, Discovery of Germanic and Latinate Clusters, was authored by Takashi Morita and Timothy J. O'Donnell. It was published on Archive in April 2025 and explores how computers can identify patterns in English words without prior knowledge of their origins. The study begins by highlighting a key idea in linguistics. Across languages, native words and borrowed words, or loanwords, often follow different phonological rules. In English, words with Germanic origins, like those from Old English or related languages, differ from Latinate words, which come from Latin or French influences. For example, Germanic words might have simpler stress patterns, while Latinate words often have more complex ones. Additionally, certain sentence structures, like the double object construction, are mostly seen with Germanic verbs. The challenge here is about learnability. From a cognitive perspective, language learners, such as children or even AI models, don't have direct access to the historical origins of words. They can't look up etymologies in a dictionary while learning to speak. So, the question is whether these distinctions can be figured out just from the sounds and patterns of words themselves. This paper provides computational evidence that yes, it's possible, using something called phonotactic information. Phonotactics refers to the rules about how sounds can be arranged in a language. For instance, in English, certain sound sequences are more common in some words than others. The researchers used this to perform unsupervised clustering, which means they let a computer algorithm group words based solely on their phonological features, without telling it in advance which words are Germanic or Latinate. They started by extracting words from a large corpus, which is basically a big collection of text from books, articles, or other sources. Then, they analyzed the phonological properties of these words, like their syllable structures, stress patterns, and sound combinations. Using Bayesian learning, a statistical method that deals with uncertainty and probabilities, the algorithm grouped the words into clusters. What they found was fascinating. The clusters that emerged from this process largely matched the traditional etymological categories. In other words, words that linguists classify as Germanic tended to group together, and the same for Latinate words. This suggests that the phonological differences are strong enough to be detected automatically, even without explicit labels. Moreover, these computer-generated clusters didn't just replicate known distinctions, they also recovered various linguistic generalizations from previous studies. For example, the paper notes that Germanic words often align with specific stress rules, and the clusters reflected that. They also touched on how Latinate suffixes, like those in words ending in -tion or -able, tend to attach to roots of similar origin, and the model picked up on these patterns. One particularly interesting aspect is the double object construction in English syntax. This is a sentence structure where a verb takes two objects, like, give me the book, which is more common with Germanic verbs. The study showed that the clusters correlated with this, reinforcing how phonology and syntax might be linked through etymology. But the research went further. By analyzing the clusters, the authors uncovered some previously unrecognized features. For instance, they might have found subtle phonological patterns that hadn't been documented before, such as certain rare sound combinations that are more prevalent in one cluster than the other. These discoveries offer new hypotheses for future experimental studies, like testing whether human learners naturally pick up on these patterns when acquiring English. The paper emphasizes the broader implications for language acquisition models. In computational linguistics, unsupervised learning is crucial because it mimics how humans learn from raw data. Just as a child learns phonemes and word patterns from hearing speech, this approach shows that etymological-like categories can emerge from phonotactic data alone. This has applications in AI, such as improving speech recognition systems or developing more accurate language models that account for historical influences. The study was supported by various grants and institutions, including those from Japan and Canada, reflecting international collaboration. The corresponding authors are Takashi Morita from Chubu University and Timothy J. O'Donnell from McGill University. In terms of methodology, the researchers likely used advanced techniques for machine learning, given the mention of Bayesian learning. This involves probabilistic models that update beliefs based on evidence, which is ideal for handling the variability in language data. For example, words can have different pronunciations or contexts, but the algorithm was able to find consistent patterns. One potential limitation, though not explicitly stated, is that this is based on written corpora, which might not fully capture spoken variations. Still, the results are promising for understanding how phonological rules could be learned in real-time language use. Overall, this work bridges computational modeling and linguistics, showing that the Germanic-Latinate divide in English isn't just a historical footnote. It's encoded in the very sounds of the words themselves, making it accessible for learning systems. This could inspire more research into how other languages handle loanwords and native vocabulary through similar computational lenses.